Good morning, boys. Today we are focusing our lesson on building a function machine and then eventually use it to solve the problems given. And we are going to build these function machines from real life situations. We are going to work or discuss a few examples together, and then you will be able to do your homework, which will be very similar to this lesson. For example, the first example, here is the function machine for working out the time needed to defrost bread. The letter P stands for the number of grams of bread, and the letter Q stands for the number of seconds needed to defrost this bread. Now, if P is equal to 120, so that is the function machine, it's drawn already. P is the number of grams of bread, and Q is the stands for the number of seconds. And you need to divide the number of grams by 2 to obtain the number of seconds needed to defrost the bread. Now, we're going to answer the following questions. If P is 120, what is Q? So, we are given the input to find actually the output. So to find Q, we need to do 120 division by 2 is equal to 60. Q stands for seconds, so it's 60 seconds. So Q is equal to 60 seconds. Okay, that's the first one, question A. The second one, if P is 80, what is Q? P is 80, so we need to find the output again. So 80 division, we follow the function machine, 80 division by 2 is equal to 40 seconds. All right, so Q is equal to 40 seconds. Now, if a loaf weighs 140 grams, how long does it take to defrost? Again, we are not given the P or the Q. We are given the question in words, so to speak. So, if a loaf weighs 140 grams, that means that P is equal to 140 grams because P stands for the number of grams of bread. So we have the input here, and how long does it take to defrost? That is represented by Q because Q stands for the number of seconds needed. So 140 division by 2 is equal to 70 seconds. So Q is equal to 70 seconds. Okay, that's the first example where the function machine was already drawn. Now the second example, we have to draw the function machine itself. Now, in order to cook a chicken, it takes 20 minutes per kilogram plus an additional 30 minutes. So irrespective of the weight of the chicken, all right, you have another 30 minutes for the chicken to cook perfectly. You need 20 minutes per kilogram plus an additional 30 minutes. Now, question A, draw a function machine to represent this situation. Use X as the number of kilograms that the chicken weighs and Y as the time taken to cook the chicken. Okay, the total time taken to cook the chicken. So, X is the input. X is the input. We need 20 minutes per kilogram. So if 1 kilogram takes 20 minutes, 2 kilograms takes 2 times 20. So it would be 40 minutes, okay? We are multiplying the number of kilograms by 20. So first, so to speak, mathematical operation is times 20. And then, irrespective of the kilograms that the chicken weighs, we have to cook it for a further 30 minutes. So plus, we need to add the 30, and we end up with y, all right? Because y is the time taken, the total time taken to cook the chicken. Okay, so that is the function machine. X, we have to multiply it by 20 because it takes 20 minutes per kilogram, and then additional plus 30 minutes, irrespective of the weight of the chicken. Okay, now question B. Question B. In question B, we have how much would a 5 kilogram chicken take to be cooked? So we need to multiply the 5. X is equal to 5, okay? So X is equal to 5. We need to multiply the 5 by the 20. That is equal to 100 minutes, yes. Plus an additional 30 minutes. So 100 plus 30. The answer is 130 minutes. The total time is represented by y. So y is equal to 130 minutes. Okay. Now, if a chicken takes 1 hour 10 minutes to be cooked, so now we are given the total time. Can you find the weight of the chicken? So this time we are given y. Y equals 1 hour 10 minutes. If we convert it to minutes, because y is in minutes, that is equivalent 60 plus 10, that is equivalent to 70 minutes, a total of 70 minutes. So this chicken took a total of 70 minutes. We are given y, we are given the output. We need to find the input, okay? So we need to find the input. So, mela. We need to work everything in reverse. So we need to subtract we need to work everything in reverse. If we work everything in reverse, we encounter the plus 30 first. So we need to, instead of the plus 30, we work out the opposite. So we need to subtract 30 now. And then instead of times 20, we need to divide by 20. So 70 minus the 30, that is equal to 40. And then we need to divide by 20. 40 division by 20, it's 2. And that is the weight of the chicken, 2 kilograms. Okay? That is number 2. We had to find the input given the output. Now, number 3. An approximate rule for changing from degrees Celsius C to degrees Fahrenheit F is double C and add 30. Now, question A, we are asked to draw a function machine to convert degrees in C to degrees Fahrenheit in F. Take C as the temperature in degrees, so that is our input, and F as the temperature in degrees Fahrenheit. So if we had to draw that function machine, we are starting with an input of C. We are doubling it, so the first function is multiplication by 2. And then add 30, so plus 30, and we end up with F, the degrees in Fahrenheit. Okay, so that is the function machine. Now, the first question. what would be the temperature in degrees Fahrenheit of a temperature of 15 degrees? So now we are given the input to find the output. So 15 degrees times 2, that is equal to 30 degrees. Then we have to add 30, so 30 degrees plus 30. 30 plus 30, 60 degrees. So F is equal to 30 degrees Fahrenheit. Okay? Fahrenheit. Okay? Question C. What is the temperature in degrees Celsius of a temperature of 12 degrees Fahrenheit? Now we are given the Fahrenheit. To find the temperature in degrees, so we are given the output to find the input. We must work in reverse. So let's look at the function machine first. We have to work in reverse. The first mathematical operation that we encounter when we work in reverse is the plus 30. So instead of the plus 30, we subtract 30. And then instead of the times 2, we divide by 2. Okay? So let's work it out. The temperature in Fahrenheit is 12 degrees Fahrenheit. We have to subtract the 30. Now, positive 12, so to speak. So positive because it has a positive sign in front of it. Minus 30, all right? It is minus negative. I have 12 in my pocket. I need to give 30 euro to the shopkeeper. So I still owe him 18 degrees. Negative 18 degrees. Negative 18. Division by 2, instead of the multiplication by 2, we divide by 2, is equal to negative 9 degrees, and that is negative degrees Celsius. So that is our answer, negative 9 degrees Celsius. Okay, we had to find the input given the output. So we had to work everything in reverse. Now, we need to draw a function machine in question D to convert degrees Fahrenheit to degrees Celsius. So, our output would be our input now. So, we start with F, but we need to work in reverse. Okay? The first mathematical operation, let's look at the previous one. The first mathematical operation that we encounter is the plus 30, so we need to subtract by 30. The second mathematical operation is times 2, so we need to divide by 2, okay? So let's work it out. So we need to subtract by 30 and divide by 2 to obtain the C. Alright, to obtain the C. It's similar to what we've worked in question C, but obviously now we have to draw a function machine, okay? Now, question E. Write an equation to represent the above function machine. We have to write the equation, alright? So instead of drawing the function machine, we have to write it as an equation, okay? So we have to say so we have to say F. What should we do with F? We have to subtract by 30 and then divide all the answer by 2. To divide all the answer, we have to divide all over 2 is equal to C. Okay? If you had to check your equation, let's say that we have to work with 12 degrees Fahrenheit, just like in question C, all right? And we have to obtain a negative 9. So we start with 12 and obtain a negative 9. So the F is 12. So check. The F is 12. So 12 minus 30 division by 2, positive 12, it is negative 18 division by 2, which is equal to negative 9 degrees. So the Celsius is Celsius, okay? We have to check. So we obtained a negative 9 degrees Celsius. So, so to speak, as you can see, our equation is correct. Okay, that is all for today, boys. Now the homework is very similar to this lesson. Just read carefully each part of the question. All right. If you get confused, just insert numbers as I've just substitute with numbers, just as I've just done in question E. Okay, and then don't forget, it is very important to upload your homework. Okay, good day for now, boys, and take care.